Welcome all to SPT Online Capsule classes. Today we are going to do a numerical question based on dual nature of radiation and matter. The question is to find the ratio of the de Broglie wavelength of proton and alpha particle which have been accelerated through same potential difference. So basically we need to calculate the ratio of wavelength of proton to wavelength of alpha particle, and they both are accelerated under the same potential difference. That is something we need to note. Now, what is de Broglie wavelength? De Broglie wavelength is nothing but lambda equal to h by p. Lambda equal to h by p. So this is one formula that we should not forget. Lambda equal to h by p. What is p stands for? P stands for momentum and h stands for Planck's constant. And momentum p is equal to square root of 2 times mass times energy, root 2me, where E is equal to charge times potential. Okay, but in this case the potential that we are applying for alpha particle and proton, they both are same. So now the de Broglie wavelength lambda becomes h divided by square root of 2 times mass times charge times potential. Now if you take the ratio between the wavelength of proton to wavelength of alpha particle, what will you get? It will be h divided by square root of 2 times mass of proton times charge of proton times potential whole divided by h divided by square root of 2 times mass of alpha particle times charge of alpha particle times potential, from which you can see that Planck's constant will get cancelled, 2 will get cancelled, v will get cancelled, and what will be left? It will be square root of mass of alpha particle times charge of alpha particle divided by mass of proton times charge of proton will be left. What is mass of alpha particle? Mass of alpha particle is 4 times mass of proton. That's because one alpha particle contains 2 protons and 2 neutrons, and it is equivalent to a helium nucleus. The charge of alpha particle consists of 2 times charge of protons. Now if you substitute these two into that ratio, lambda proton divided by lambda alpha particle, what will you get? You'll be getting square root of in the place of mass of the alpha particle we will substitute 4 times mass of proton. In the place of charge of alpha particle we will substitute 2 times charge of proton divided by mass of proton times charge of proton, and what will you get? Mass of proton will get cancelled, charge of proton will get cancelled. What's left with is square root of 8. Square root of 8 is 2 root 2. So the answer is 2 root 2 is to 1. So that's the final answer for this question. The question was to calculate the ratio of the wavelength of proton to alpha particle under the same potential difference. The answer is 2 root 2 is to 1. Thank you.